Hello and welcome, or probably welcome back, to part 2 of our introduction to high-performance computing at NC State, specifically with our HPC cluster, Hazel. So in part 1, we went over the acceptable use policy, we talked about how to access Hazel itself, and a review of basic Linux commands. Today is all about storage, options, and file transfer tools. Essentially, where do you put stuff on Hazel and how do you get it there? So, storage considerations. When you're using your own personal computer, or even most work computers, most of your considerations for where to store files really come down to organizational preference. Maybe you like to have a couple key programs stored on your desktop that are easily accessible when you start up your computer. Maybe you like to have some complex but consistent file hierarchies that make your code or data easy to share with other people and navigate to when you come back 6 months later. Maybe you're one of those people who just have a giant downloads folder with every single file you've ever downloaded, and you just search by name every time you need anything. However, once you scale up to something like an HPC cluster, storage decisions start mattering more. Because not all storage is created equal, whether due to management choices, or the file system, which is the organizational structure used to access information on a storage location, or the hardware that storage is on. Different storage locations can have differences in terms of capacity, redundancy, so whether something's backed up at a given location if something goes wrong, speed, how quickly resources can read from and write to that location, networking, so how that storage location is connected to other infrastructure, and expense. Maybe you have to pay extra to get premium storage. Maybe the HPC administrators need to make expense decisions on whether choosing storage that is really, really good at everything, but more expensive, or different storage options that are good at one thing or another thing and save the university money. I like to look at it as what bag you use to go on a trip. If you're just going on a day trip to somewhere like an amusement park, maybe you just need a bag that prioritizes convenience and speed of access. Something like a fanny pack to store, a wallet, maybe a tiny water bottle, and some sunscreen. On the other hand, if you're going to hike up a mountain, it's going to take multiple days and you're going to have nowhere to resupply, you need a pack that can handle both the rigors of that exercise, limit the strain on your body, and hold everything that you need to live. But just like taking a hiking backpack to, your first day of school or your amusement park might be a little bit overkill in terms of the overhead weight and the investment involved, and trying to hike the Appalachian Trail with a fanny pack can only go poorly. Using the wrong storage for your code or your data can either make your code less efficient or completely non-functional. For those reasons, it's important to understand what storage options are available to you and when to use each one. Every user on the cluster will start with access to 2 basic storage options on Hazel. The first is your home directory. This is your landing zone. This is where you will automatically start when you log in, and it's where a lot of hidden configuration files exist that help you have a consistent environment each time you start up. This is a good place to store things that you need long-term, but they don't take up a lot of space. Things like important scripts, small application source code, or executables are great things to store in your home directory. However, it's important to note, each user only gets 1 gigabyte of space per their home directory. So large Conda environments, large data sets, large applications, all of these can easily fill up your home directory very quickly, and you'll end up not having enough space to store anything. One important perk of storing things in your home directory is that it is backed up daily, and deleted files are retained for 7 days. So, like I said, this is a good place for storing important things that don't take up a lot of space. On kind of the opposite end of storage location options is your Scratch directory, which is stored in /share. Each HPC group has its own share directory, which often corresponds to an HPC project, with each user typically having their own folder within that group share. Scratch space is high capacity and high speed. This is rapid reading and writing and is ideally suited for compute tasks that require a lot of creating new files, deleting those files, reading in files, the kind of things that you are probably going to be using the HPC for and using actual jobs for are the things that are going to benefit most from the Scratch directory. For this reason, we'll go more into job submission later, but jobs should be submitted from /share or should be written in such a way that they will, by default, read and write to a /share directory. Doing otherwise both makes your job less efficient and makes home or whatever other storage location you're using less efficient for other people. Scratch starts out with some pretty decent quotas available, so there's a lot of space to put what you need. However, Scratch space is not backed up. This is not meant for permanent storage, and actually files are purged after 30 days to maintain capacity for other users. As a note, this is listed explicitly in the acceptable use policy, but trying to find ways to work around this file purge is a violation of the acceptable use policy. And if we find it, we will stop it. But never fear, there are options for more permanent storage that are backed up. If you do end up needing more long-term storage space than can be found in your home directory, there are two other options available on Hazel. First is user apps, which is found under user/local/user apps and then generally followed by a project name. These are available on request to anybody who owns a project. This is typically going to be your PI. And these spaces are specifically designed or intended for user-maintained applications and or environments, like Conda environments. Generally those that take up more space than would be practical to use the home directory for. They come with a default quota of 100 gigabytes, but this quota can be adjusted for specific use cases where it's necessary. One important consideration when you're designing your scripts to utilize compute resources is that you cannot write to user apps from a compute node or through the Globus file management tool, which I'll show you later. On the other hand, research storage is a more general purpose research storage location intended for research data, as well as user-maintained applications or environments, similarly to user apps. However, these are managed separately from your HPC storage. Each faculty member can request their own research storage share through the research storage portal, and projects through the RED system, that is grant-funded projects, can also receive their own share. Shares start at 2 terabytes, but you can request up to 30 terabytes for a share at no additional cost. The added bonus of storing things in research storage is that it's available on Hazel, but it's also available on any on-campus computer. You can mount research storage to it. You can also mount research storage to off-campus computers through the NC State VPN. Unlike user apps, you can access and share research storage through Globus as well, which I will show you shortly. As far as managing your storage, there are a couple Linux commands that can be useful to run on the cluster. First is quota. This one's fairly straightforward. I always recommend adding -s. That leaves your numbers for how much quota space you have or how much space you're currently using in human readable numbers, for instance megabytes and gigabytes rather than just bytes. Running just quota s will just run a quota for your user to show how much space is in your home directory and how much you're currently using. You can see here that I have about a gigabyte of space, and I'm currently using about a third of that, 335 megabytes. You can run the same command using -g followed by a group name. For instance, if you look at my primary group, echo the group variable, see that I'm in the RFS group, and if I run quota-s-g, that group, you can see here that I'm currently, the RFS group is currently using 485 megabytes over 100 gigabytes of available space for group storage. Now let's say you're getting close to your quota and you're trying to figure out where all of that space is. DU can be useful. That's short for disk usage. -s for summarize, which adds it all up instead of doing it per file. And -h, which is human readable, always useful. So if I run it on, let's say, my current directory, which is my home directory, you can see that it's 337 megabytes, which is pretty close to what it shows my current usage is using the quota command. But if I go to my research storage, which I've made as a link, and run du-sh, takes a little bit longer, but it should show you the total amount of data currently in my research storage partition, which should be substantially larger. And you know what, we're not going to wait for this to finish, but if I really wanted to know, that's how I would check. Another useful command that you actually don't see a lot is tree. I'm going to run it here in my research storage, and I'm going to use the -d to only show folders. And I'll say -l and make it 2 levels. This is a useful way to see how your current folders are organized, but notice that I have a lot of folders even with just 2 levels down, so it can be a bit overwhelming. But if I go instead to my home directory and do tree-d, even with no levels, it's fairly straightforward, and it can help you navigate where exactly you're storing things. And then you can move to, a specific folder or subfolder and run du-sh again to see how much stuff is in there, and you can slowly kind of put together where all things are stored. Finally, while your primary group will be under your group variable, it's entirely possible that you're in multiple groups at once through different, collaborations and affiliations you might have. Using the groups command shows you all the groups you are in. You can see that I'm in a decent number of groups for my various tasks, but I can run a quota on a different group if I'm using that group storage to check it out and see how much I'm using. You can see it's different than if I just run it with -rfs. So, you now know where to store your stuff. The question is, how do you get the information that's on your computer or your workstation or wherever it currently is stored onto the cluster? This list is by no means exhaustive, but if you're already comfortable with things like rsync, SCP, or mounting research storage, you're welcome to use these methods. But these are the 3 methods that we recommend you use for transferring files to and from the cluster. The first is SFTP. SFTP stands for Secure File Transfer Protocol. This is a primarily command line tool, which does have some graphical clients that you can install, like FileZilla, to kind of give a more windowed picture as you're interacting with your files. But the general purpose is to navigate local and remote storage with a fairly similar interface, and then use get and put commands to either copy information from your local machine to your remote machine, or vice versa. If you're interested in more of a graphical feel and you don't want to install anything yourself, Open OnDemand, which you already saw in the previous segment, has a file management interface. This allows you to see your files in your folders, navigate through them, and has the option for fairly straightforward and simple uploading and downloading. This is generally a recommended tool if you're just uploading a couple files or folders, and if you don't need your transfers to run for a particularly long time, such as if you're trying to move terabytes of data or something. If you are trying to move more data at once, Globus is an alternative interface that works really well. Globus is a whole file transfer ecosystem, which includes a lot of tools that you probably don't need to get into. But the 2 that are of relevance to basically anyone who wants to use it are the web interface and the installable client. The web interface allows for transfers between Globus endpoints, which includes research storage and our HPC. And then the installable client, Globus Connect Personal, allows you to turn your own machine, whether that's your personal machine or like a workstation, into a Globus endpoint, which you can then use as a either start or end point for triggering transfers. Globus is ideal for very large transfers. This includes very, very large files or many files and folders. It's ideal for this in part because it parallelizes the transfer, having multiple streams of transfer happening at once, but it's also resistant to interruption, meaning if your network connection gets interrupted, Globus will keep restarting the process until it is complete, and then will check file integrity once it's done. There are also a number of options for customizing this transfer, which I'll get into in a short demo. One additional benefit of Globus is that you can set up scheduled transfers. Like let's say at the end of the week, you want to regularly transfer all of the output data you have on HPC to somewhere like Google Drive. You could set up a scheduled transfer that takes care of that in the background without you having to watch and worry about it. So I'm going to really quick take you through an example using each of these file transfer methods. I'd suggest you pause as needed so you can follow along and try things out yourself. That way you have a good sense on how each of these feel. And in the future, you can decide which method to use based on your own personal preferences and what you're trying to transfer. And we're going to start with SFTP. To start an SFTP session, we're going to use pretty similar syntax to what you've used previously, or at least seen previously for an SSH session. In this case, SFTP, your Unity ID, followed by login, hpc.ncsu.edu. This will ask you for your typical NC State password, and a dual push. You'll know you're in when you see this little SFTP prompt, which probably vaguely reminds you of an SSH prompt. During an SFTP session, you can use a lot of the commands that you're used to for file navigation in a typical terminal interface. For instance, pwd tells you where you're currently located on your remote destination. ls shows you the contents of that directory, in this case my home directory. mkdir lets you make a new directory. Call this, let's say, remote destination data destination. Right. ls shows that that's there now, and it wasn't there before. And cd allows you to enter a new directory that you can access with tab completion. On the other hand, you can still list the contents of your local directory and navigate through your local directories by adding L before any of these commands. For instance, LLS shows me the very large and probably needs to be organized contents of my local home directory. LCD desktop lets me navigate to desktop. LPWD shows that I am in /home/dmdebris/desktop, which exists on my local machine but not on HPC. And as you can see, PWD still shows my remote working directory being remote data destination. So let's say I want to move one or more files from my local machine to the remote machine, in this case the HPC cluster. The command for that is put. Put is going from local to remote, and it will automatically assume that that is how you're using it. In this case, put allows tab completion for your local directory for the first option, data for HPC, and let's do just a specific file for now. And we're just going to put it in my current working directory. And if you use ls, you can see that I now have data_file in my remote directory. pwd, still in that remote data destination. You can also copy entire folders using put, but you may need a -r for recursive, kind of like when you were using CP earlier in the previous module. Put can also be used to copy the entire contents of a directory. For instance, put -r data for HPC into this current directory, copies both the file and the folder. So now I should have both data for HPC as well as data file.txt in this current directory, ls. And you can see that I have both that file and that folder. And if I navigate into that folder, I have another copy of this file. cd ... still works, as does a single dot. Let's say now that you have the products of something you've done in HPC, maybe something you've modeled and you want to be able to pull down your outputs to analyze your results. The opposite of put, which would allow you to put something from your local machine on a remote machine, is get, which allows you to copy something from your remote machine to your local machine. So we're going to cd back up a little bit and ls, and pick some random file that we want to get. In this case, I am going to use get on Derek waxworm.sh into my working directory. Now, if you notice, I did cd up once, ls, but I didn't lcd, which means I'm still in the directory I was in before on my local machine. If you do lpwd, you can see that I'm currently on desktop. So if I exit, which you can do using exit, quit, or buy, and now on my local machine, if I cd to my desktop and list, searching for waxworm, you can see that derekwaxworm.sh is now on my local machine. If you're interested in learning more of the subcommands within the SFTP terminal, you can use man SFTP to see your other options for specific commands. This includes things like looking at df to see the size of the contents of a directory, or remove directory if you're trying to delete something. A lot of the file navigation type commands that you have in a basic terminal interface, you will also have an SFTP, but not 100% of them. While SFTP is a perfectly functional option for uploading or downloading files to and from the cluster, OnDemand gives you a visual interface that you can use through your browser, meaning you don't have to navigate the terminal anymore. You can actually look at your folder structure and navigate to things with point and click as you are probably more comfortable using. We're going to go to OnDemand, which in this case is servood.hpc.ncsu.edu. And go to Files, and the option underneath is home directory. So you can see here, this is a visual representation of the files in my home directory and the folders in my home directory. I can navigate to a folder by clicking scripts, and you can see some scripts inside. I can download by clicking select and download, or by clicking the 3 hamburger dots here and clicking download here. You also have options to rename files, move files, in some cases open files, if there are text-based files. And you can also upload files. Click upload, browse files here, and let's say we're going to upload some arbitrary screenshot. And now in my home directory, we should have a screenshot, which we do. I don't actually know if this will open. It does open, that's great. And let's say you uploaded a file to the incorrect place. You can select the file, click copy or move, and then navigate to the folder that you'd like to move it to. And now you can see that the screenshot is in my Scratch folder. Open OnDemand can be a good blend of the simplicity and straightforwardness of SFTP with the windowed interface of Globus, which I'll show you next, and is well suited for most forms of uploads and downloads if the files are relatively small, things that can be taken care of in terms of an upload or a download in about a minute. If it's going to take longer than that, you risk the upload or download being interrupted due to some kind of connectivity issue, in which case I'd recommend checking out our last recommended option, Globus. Now, Globus is a file movement and sharing tool with a lot of other bonus functionality that I'm not going to go into during this tutorial, but it was created by the University of Chicago in connection with Argonne National Labs, and is available to a lot of different institutions and nonprofit agencies, including things like USDA and USGS, and allows for the movement of files from storage locations at those different institutions or associated with members of those different institutions, such as from your workstation to the storage at Pittsburgh Supercomputing, or in this case, your personal computer to and from our HPC storage options. So if we go to app.globus.org, doing this through an incognito tab so you can watch the login cycle. You look up your organization, which is North Carolina State University. Click continue. Go through your typical Shibboleth login experience that you're all used to, including the classic duo push, and you will see a windowed style web interface with options for collection and path. For collection, we're going to look up NC State HPC. And you can see the NC State Hazel HPC cluster, which if you click, and click continue if it requires a consent, should show you the contents of your home directory once again. I'm not going to go into everything you can do from this interface, but some notable ones include being able to rename files or folders. Call this compute test renamed. Now it's been renamed on the HPC cluster. You can delete specific files using the delete function. And you can also upload files from your computer. I select, let's say, this video file here, which I don't know if you can see. And you can download specific files, which is just a normal web download. You can even navigate within specific folders, both by entering the path name up here, as well as, clicking and dragging and going up one folder, etc. Globus also has a share function, which allows you to create guest collections, essentially windows into your storage to share with either internal collaborators at NC State or external collaborators. But this option doesn't work for the HPC, the Hazel HPC cluster endpoint, though it does work for research storage, but for that reason it's outside of the scope of this training. You have additional options available through this menu here, including monitoring current and past activity, viewing what collections you have access to and navigating to new collections, but those kind of upload and downloads through this sidebar here don't take advantage of the full functionality of Globus. They don't have the resiliency. You're not going to get any kind of email notifications when they're complete. They're not resilient, especially to network interruption. Additionally, with certain cases like entire folders, you simply can't download them. The download option is completely grayed out. For the full functionality of Globus, you want to be doing Globus transfers between endpoints. You can open this two-pane view here and select another endpoint. In this case, I'm going to select NC State Google Drive. Click it, and you may need to do some additional consents or authentications here. But if you navigate to something like, let's say, My Drive, and a folder within your drive, you can transfer a file or a whole folder from the HPC cluster to another endpoint, whether that's your Google Drive, research storage, an external computing or storage system, or your own computer using Globus Connect Personal, which I'll walk you through shortly. If you're just using baseline transferring of new stuff from one location to another, you can just click Start to execute a transfer. This creates a transfer task, which will be monitored in this activity menu here. You can see the task is queued, and it will say task in progress and task complete, and will give me a small email notification when it's done. And it looks like with that little 1 that it is complete, and so if I refresh here, you can see that now a fungi share folder exists here. If you're transferring a folder that you've already transferred and you're just trying to update the contents, you can choose some of these additional options, including the sync option, and choose how you want to define your sync with either just modification time, file size, or whether or not the file exists as your fast, simple options, or checksums if you want to check the contents of every file and transfer any file that's different from your source to your destination. And note that you can start from the right to the left or from the left to the right, depending on which start you click. There are a couple other options that can be useful, particularly preserving source file modification times, which can be nice if you're trying to keep track of when files were modified after transferring them without just having the transfer date be the modification time. Filter rules to ignore specific files. Options to disable different email notifications. For instance, if you only want an email notification if you fail, you can click Disable Success Notification. And finally, if you want to schedule a transfer to occur regularly, you can enter in the schedule start date automatically today if you just click Start, and repeat every number of days, hours, minutes, etc. As I mentioned before, if you're just using the Globus web interface to go from your local machine to a Globus endpoint, you're not really leveraging the advantages of the Globus system. You can upload and download files, but you can't download whole folders, so you can't upload folders. And your transfers don't have that built-in resiliency and kind of recorded, activity meter and that kind of thing that make Globus more useful in certain situations. If you'd like to tap into those advantages on your workstation, you need to install a small client that kind of lives on your machine called Globus Connect Personal that turns your workstation or just work computer or even personal computer into a Globus endpoint. Then you can conduct transfers in a very similar way to what I showed previously with the transfers between the HPC endpoint and Google Drive. Right here, you can see that I have installed Globus Connect Personal. I'm not going to go into the steps of installing Globus Connect Personal right here, but if you have installed Globus Connect Personal already and you click it, in this case I've already clicked it so it says an instance is already running, you'll see that nothing really happens visually. But if you navigate to this kind of lower menu or this upper menu up here, if you're on a Mac, and right-click that little Globus Connect Personal icon, you can click Web Transfer Files. And you can see my little workstation endpoint I have built into a little Globus endpoint, and now I could search, NC State HPC cluster, and trigger, let's say, the syncmap.csv, and I could copy it to my home directory on HPC. Same thing, it goes to your activity menu just as before. This is just a local transfer. But as you can see here, you can do something that couldn't be done through the basic web interface. Select a folder. This could be a very large folder, gigabytes or even terabytes of data. You can start your transfer and it'll continue as long as you have an active connection. We'll continue the transfer, and if the connection gets interrupted, it'll keep trying until you have an active connection again until the transfer is complete. If you'd like more info about setting up Globus Connect Personal or the other functionalities you can unlock with Globus, I'd recommend going to our documentation page at go.ncsu.edu/rfs-globus. This will have a little collection of the most up-to-date documentation for using Globus in general and at NC State specifically. And with that, we've just about wrapped up our Part 2 of an Intro to HPC at NC State, File Transfer and Storage. If you'd like to learn more or remind yourself what you learned during the segment, you can check out the HPC storage page at hpc.ncsu.edu/documents/storage. You can also check out information on Globus Connect Personal, including installation. If you do end up installing Globus Connect Personal yourself, please be aware that there's a second short configuration step to make sure that the Globus Connect Personal app can see all the files you want it to look at. And finally, you can check out the most up-to-date Globus docs at go.ncsu.edu/rfs-globus. If you're interested in learning more about NC State's research storage, you can check it out at research.oit.ncsu.edu/docs/storage. And up next, we have Part 3, Basic Job Scripts on Hazel.